Hello, Celestial Navigator students. Sorry for the distorted view of the screen, but I've got this window behind me. So let's try it like this anyway. Okay, I'm going to be talking to you about the short sight table. And of course, I'm Chris Kreitline. My email is celestenav@yahoo.com. Now, the short sight table. If you're in a location without a sight of the natural horizon, for example, on a lake or in a bay, and you don't see the horizon out there at a distance because you have land in the way, don't worry, you can still practice celestial navigation. You'll have to make a correction, but that's no problem. I'm going to tell you how to do it. Okay, here we are in a bay, and we're going to shoot the sun down to the south there, and we've got land, so we do not see the natural horizon. We've got that land in the way, but we can still do it with just adding, well, in this case, subtracting a correction. All right, the natural horizon lies on the other side of the land. We can't see it. And their land horizon, because of the physics involved, is going to be lower than the natural horizon. As it gets closer and closer to you, or as you get closer and closer to it, it's going to go down, down, down until, hey, it's under the keel of your boat and you're aground. Anyway, now you need to know how far you are from the land horizon. Now you can guess that or you can estimate it. Good luck. One way is to look at your chart plotter. If you're a math major, you can triangulate it by taking an angle, moving your boat so far, taking another angle, doing the trig involved. Well, I'm going to let you worry about figuring out how far away the land horizon is. The easiest thing, obviously, is to look in your chart plotter. You're just out there practicing anyway, so what's the big deal? Anyway, when you do all of that and get the distance, then you look up the minute correction in the short sight table. Now, this is what the table looks like. This is out of Bowditch, that voluminous volume of data on the mechanics of celestial navigation and navigation in general. This is what the table looks like. But let's jump right into an example here. Here we go. You see down here, this is the distance to the land horizon. In this case, we'll use 2 miles. It says miles, 2 miles. Here is your height of eye above the sea, your normal dip, height of eye. Say it's 5 feet or 1.5 meters. Well, you come down here, it's 2.2. 2.2 what? Well, right here is minutes. So you will subtract 2.2 from your HS. What you really do is add it to your dip. If you've got a height of eye of about 5 feet, your dip will be about 2.2 also, actually. So you'd add those together for 4.4 and subtract it from HS, just like you do dip. Now, here is 10 feet, 15 feet, 20 feet, down here to 50 feet if you're sitting on an aircraft carrier or whatever. So the question then becomes, what if your height of eye is 8 feet? Well, you're going to have to take 5 feet and 10 feet and then extrapolate the difference. Interpolate, whatever the word is, 2.2 to 3.7. Now this 2.2, of course, that's about 2.2 miles, nautical miles, when you work it all out. And this is 3.7 minutes, so that would be about 3.7 nautical miles. So 8, what is it, about halfway between these, a little more than halfway, maybe 3, 1, 3, 2, something like that. I'll let you work that out. But you're just going to have to do that, in your head if you're between 5 and 10. Which is where most of us are. If you're up on the top of some catamaran doing it, you may be up 15 feet high. No problem. You would subtract 5.1 minutes along with your dip correction from HS. So see, it's really quite easy, but that's the correction you want to make. If you don't make that correction, then you're guaranteed to be 2 miles off in your fix at least, and probably a lot further than that. So you want to make every little correction you can. But this is a table. It's very easy to use. Just look it up and add it to your dip and then subtract it from your HS. Now remember, dip is your height of eye from the horizon, from your height of eye looking out to the actual horizon. So of course you've got to subtract this. Well, because you're above, you're going to be looking over the edge of the earth. Well, same thing with this. You're still looking even further over the edge. So you've got to subtract that from HS also. Okay, so if you're in a bay or lake, you can still practice celestial navigation, no problem. Just use the short sight table, add it to dip, and subtract it from HS. Oops. You can email me to request a copy of the table right here at celestenav@yahoo.com. Okay. Try it. You'll like it.